viewers, we want to move to the next part of series and sequence, and we want today to look at the sigma notation. And the sigma notation is a very simple thing. The word sigma is actually a word to represent or to signify the Greek letter. This is the Greek letter. And this Greek letter is called sigma, and we use it to refer to or to represent the summation of or sum of. So whenever we have sum of, we use this letter here to represent that particular instruction. So when you have that thing, it tells you to add something, or they add the terms in particular sequence. Now, when we use a sigma notation like this one here, you will always have the limits. One limit will be at the top, another one will be at the bottom. Now, if I have, for example, 5, it means that I want us to get up to the term, the 5th term. And the one at the bottom, probably if I say n or t equals to 1, it means that I should add the sums from t equals to 1 to t equals to 5, meaning the sums 1 to 5. So I will have to substitute. If I have this one, usually you find that they are accompanied, the sigma notation is accompanied with a function. So if I have this as the sigma notation and this is 5, let me say this is 3, this is maybe r equals to 2, then have the function is 2r plus 3. So what we are supposed to do here is that if I have this particular expression to work with, what I need to do is to, every time, for me to get these terms, because the terms are here, but there's first when r is 2, when r is 3, let me say here when up to maybe 5. So we need to get these terms when r is 2. When r is 2 here, we'll substitute 2 here, we get 4 plus 3 is 7. Then we substitute when r is 3 here, that's 2 times 3, 6, plus this one is 9. r is 4, 4 times 2 is 8, plus 3 is 11. When r is 5, which is the last one, 10 plus this is 13. So we'll find that we'll be having the terms are, because their summation is a series, we need to have 7 plus 9 plus 11 plus 13. Those are the terms in that particular sequence, because we have the, what we call the function, or the formula for getting the functions are here. So what we just need to do is substitute, and that's what we have here today. So if we have a question here, this 5 here becomes the upper limit, the term that where you should add to. This one below one must tell you where you should start. If it is r is 3, you should start there. If it's r is 5, you start there. If r is 1, you should start there. So we look at these particular questions. You can have a sigma notation of a arithmetic series or a sigma notation of a geometric series. And we are going to see a geometric series, we'll always find that the unknown here, the letter here, is always a power. If you find that it's raised to something, that tells you that that one is a geometric progression, but it's just times that one, you just know. But another way, you cannot just substitute them and then check whether you have a common difference or you have a common ratio. Then you determine what kind of a series you have there. Now, the example one here that we are using here is a sigma notation for arithmetic series, and you can see it here. You find the upper limit is 5, the lower limit is 1. So we should start from r equals to 1 to r equals to 5, and we should substitute them here to get this term. So if we substitute r equals to 1 here, that will be 2 times 1, which is 2, minus 3 is negative 1. You see it there. Then if I have r equals to 2, I will substitute 2 here. That is 2 times 2 is 4, minus 3 is 1. You see it there. If I have r equals to 3, it is 2 times 3 is 6, minus 3 is 3. You see it there. If r equals to 4, I will have 4 times 2 is 8, minus 3 is 5. Is there. R equals to 5, which is the last one, will be 2 times 5, which is 10, minus 3 is 7. After you do this, therefore, you can use the formula for this one, the sum of n terms of an arithmetic series, to be able to calculate the sum of this particular terms, because now you can see the common difference is 2, 2, 2, 2 in each case. It's a very simple thing. If you come to the second example, which is going to be a sigma notation for geometric series, you realize that now we have the same summation, sigma 7, limits 3 and 7, but the r is now 2 power r, not 2 times r. So what we are going to do here is to substitute r here, and you realize that 2 power 3 is 8 times 5 is 40. The first term is 40. If you have r is 4, because we should r3 to r equals 7. So r4, 2 power 4 is 16. 16 times 5 is 80, the second term. R power 5, yes, 32 times. 32 times 5 is 160. And then r power 5 should give you 2 power 5, 2 power 6 now. 2 power 6 should give you around 64. 64 times 5, you should get 320. And then particularly if you have 2 power 7, should give you 128 times 5, we have 640. So these are the geometric progression. You see that there's no common difference. If you have 80 minus 40 is 40, 160 minus 80 is 80, so there's no common difference here. But what about if you take 80 divided by 40 is 2, 160 divided by 80 is 2, 320 divided by 160 is 2, 640 divided by 320 is 2. So this one now is a geometric series. So if you want to now be able to calculate the sum of the terms in this particular series, you can use the 3 formulas we have talked about before. The formula when r is more than 1 is sum of n terms equals to a into r power n minus 1 over r minus 1. But if you have r is less than 1, then you will have sum of n terms equals to a into 1 minus r power n over 1 minus r if r is less than 1. But we also talked about now in our previous lesson the sum to infinity. The sum to infinity here will be a divided by 1 minus r if you're dealing with that. So the question, the choice will be yours based on what the question is asking you to do. Now I want us to see examples. Plus 1. Now you realize that what the question wants us here to deal with is to get the summation of terms, where the formula for each term is going to be this, but now we want to calculate the sum of 20 terms of this one. Now the sum of the 20 terms, we don't need to really go to big deal. What we just need is to get common difference, because this one I said 4 area means this arithmetic series. We need common difference and we need the first term. Once we can get those ones, we can use the formula to get the sum. We don't have to get all of them in a row, like from R1 to R20. That's going to be so much of difficult work. So the first thing I need here is just to get, for me, probably first 3 terms. So that from those first 3 times I can get common difference and also the first term, because I know the limit that I should count. The value of n is 20 here. So I'll say here the first term a, or let me say first term. The first term here will be 4 into r is 1 plus 1. So the first term here will be 5. What about the second term? The second term will be 4 into 2 plus 1, which is 4 times 2 is 8 plus 1 is 9. The third term will be 4 into 3 plus 1, which will be 4 times 3, 4 times 2, 3, yes, sorry, 3. 4 times 3 is 12 plus 1 is 13. So we realize that the terms are 5 plus 9 plus 13 plus, it continues there up to 20 terms. Where do I get the 20 terms? Is here. They have talked about is the upper limit there. So from this one here, we can just be able to get the common difference. We know from here a is 5, and the common difference d is 9 minus 5 is 4. Even if you say 13 minus 9 is still 4. Now that I have a, I have d, I have n, and I know here n is 20. What I'm going to do is that the formula for calculating sum, I know sum of n terms is given by n over 2 into 2a plus n minus 1 d. This is the formula of n terms. Now of the sum of n terms. Now the sum of n terms here, we want to get it. So this is sum of 20 terms will be equals to 20 divided by 2 into 2a, and a is 5 plus n, and n is 20 minus 1 times common difference, which is 4. I go there. So we know that this is 10 into 10 plus, we know we have here is 20 minus 1 is 19, so 19 times 4 is 76. So we'll have here 10 times 86, and times 86 is 860. Viewers, you see that how that has been very easy. You realize that we didn't have to get the first term, the second term, the third term, the fourth term, the fifth term, up to the 20th term. That was not necessary, because what we needed is just to get the sum of the first 20 terms starting from n r equals to 1, and we really did that. So we got that the first term was 5. We continued with that, and then from up to the first and the third term, we got, from here we can get A and we can get D. That's what all we need for this particular formula, because n already we know is n is 20 terms. So example 2 that we are looking at now is here reads, for the series the summation of the terms from the first term to the fifth term, where 3 r plus 1 represents the term of each term of this series. Now we need to write out all the terms in this series, and we said that for us to write all the terms in the series, we just have to be substituting r1, r2, r3, r4 up to r5 in this function. Each time we substitute r1, we get the first term, r2 we get the second term, and so on. So we are going to say that the first term here, the first term will be given as 3r, and r is 1, so 1 plus 1. That will be 3 times 1 is 3 plus 1 is 4. And then we have second term. The second term, when r is 2, we are going to have 3r, and r is 2 here, plus 1. You realize that this will be 3 times 2 is 6, plus 1 is 7. Then the third term, when r is 3, we are going to have 3 times 3 plus 1, which is going to be 3 times 3 is 9, plus 1 is 10. Then we have the fourth term, when r is 4, is going to be 3 times 4 plus 1, which is going to be 3 times 4 is 12, plus 1 is 13. Then finally the fifth term, because the upper limit was 5, where r is 5, so it's going to be 5 into 5 plus 1, which is 5, 3 here. 3 times 5 is 15, 15 plus 1 is 16. So we have the terms here will be, the terms in a series will be 4 plus 7 plus 10 plus 13 plus 16. Those are the terms of this series. Now find the sum of the terms in the series. Finding the sum, we can simply add manually by saying, we say method 1 could be simply adding them. Method 1 could be simply saying the sum will be 4 plus 7 plus 10 plus 13 plus 16, which should give you, so you have 4 plus 7 plus 10 plus 13 plus 16, we should get 50. That should be the sum of these terms. But you can also use the formula method. The formula method is method 2, which we said is sum of 5 terms. Sum of 5 terms in this case will be 5 over 2 into 2. Let me give the formula first. N terms is n over 2, 2a plus n minus 1 d. So if this is the formula, then we can say sum of 5 terms will be 5 over 2 into 2a, and a is 4 times 4 plus n is 5, so 5 minus 1. D is 3. D is 3 there. So we are going to have 5 over 2 times 8 plus 5 minus 1 is 4 times that is 12. So we are going to have here 5 over 2 times, this is 20. 20. So if you have 20 here, 2 goes into 20 10 times. 10 times 5 is 50. So viewers, that's what you can do for this question here where n is few numbers. You can simply add manually without having trouble doing that. Let's go to example 3. So our example 3 is dealing now with probably a geometric progression. You can see this is this 3 is raised to power k. So that is an indication. I said if it is times, then it's an AP, or I mean arithmetic series. But when you see it's power raised to, then that one it signifies a GP, a geometric progression, so, or a geometric series. What we are going to do here is the same thing. We are going to be able to determine, we are needed to look for this term for 1 to k equals to 12. We substitute each in there. But I said we don't need to do much. We just need maybe to do the first 3 terms, and then from there we can solve our problem. So this will be our, we are going to say here, if I say the first term of this GP will just be 5 times 3 raised to power 1 minus 1. And you see that I'm substituting k equals to 1 here. So when 1 minus 1 is 0, 3 power 0 is 1 times 5. So the first term here is 5. If I go to the second term, I'm going to say 5 times 3 power 2 when k is 2 minus 1. So we see we are going to have here 2 minus 1 is 1. So 3 power 1 is 3 times 5 is 15. So the second term is 15, and the third term, for that matter here, will be 5 times when k is 3. So it will going to be 3 minus 1. No, times 3 power 3 minus 1 will be 3 minus 1 is 2. So 3 power 2 is 9. 9 times 5 is 45. So we are going to see these numbers moving this way. 5 plus 15 plus 45 plus a number that we don't know, and they are going up to 12 terms. They are going up to 12 terms. So what we know is that this one here we need to get A, and A is 5. A of this series is 5, and R will be 5 over 15 over 5, which is 3. You can also have 45 over 3, is still going to be 3. So we know that this one here, the value of R is greater than 1. So we should use the formula Sn equals A into R power n minus 1 over R minus 1. So this one, the sum of the first 12 terms will be A into R is 3, so 3 power 12 minus 1. Let me say A already is 5. Let's substitute 5 here, minus 1 here, over 3 minus 1. So you'll say here, first term here is 5 times. So we have 3 power 12 minus 1 is going to be 53,1440. Everything here divided by 2. So if you have that one times 5 divided by 2, we are able to get 1,328,600. That is the answer that we need to get. Now I want us to go to the second, fourth question, which is example 4. Find the value of 12. Higher limit is 12, k 12, k 5, and this one is what we have. So we are going to say the first term here, where k is 5, is our first term. Let me say first term. First term is equals to 5 times 3, k is 5 minus 1, equals to, so when k is, that's 3 power 4, 3 power 4 is 81 times 5 is 405. So this is our first term. The second term for this one here will be 5 times 3, we substitute 6, so it will be 6 minus 1, which is, so let me say 3 power 5 to 43 times 5 is 12, 15. This third term, I said we only need 3 terms, is 5 times 3, 7 minus 1 will be 3 power 6, that's 729 times 5, you get 36, 45. So we know that these terms are this one, 4, 0, 5, plus 12, 15, plus 36, 45, plus, and now the question here is, how many terms are here? We cannot assume there are 12 terms, because we are starting from K5 to K12. So if you have K5, 6, 7, 8, 9, 10, 11, 12. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8. With other words, we can say 12 minus 5. But you know that 5 is included. So when 5 is included, we should take 5 minus 4, the lower number, or 12 minus 5 plus 1, because 5 itself is included. So we are going to have the sum of 8 terms here. 8 terms, not 12. And I want you to be very careful. The first example, you say 12 terms because K was 1. But in this case, K is starting somewhere along the way 5. So we have to be very careful with that. So what we are going to do here is that the sum, A we know is 405. And R is going to be 1215 over 405. And 1215 divided by 405 is 3. Still 3, and we know n here now is 8. So we are going to say the sum here will now be sum of n terms. We know that still r is greater than 1. So we are still going to use the formula a into r power n minus 1 over r minus 1. So sum of 8 terms will be a is 405 into, it will be 3 power 8 minus 1 over 3 minus 1. So this will be 405 times 3 power 8 is 6561 minus 1 is 65, 60. Everything divided by 2. So if I multiply that times 405 divided by 2, I get 132,400. That is the answer that we get. Thank you very much, viewers. Please subscribe to our channel so that we can learn with you during this time of coronavirus. Thank you very much, and let's meet you next time.